All right, exercise 14H. So we did something quite similar in our quiz there. We just did 4A, something similar there. We're now going to try out B. Okay, so 4B, let's have a look at 4B. We have root 2 of sine of x plus 1 is equal to 0. They tell us that x, which is the angle, is between 0 and 2 pi, so it's in radians now. So it means your answers have to be in radians. Your goal is to find x. Just like everything else that you've ever been doing, your goal is to remove every other variable or parameter so that you can get just x. So in this case, I can see there's a plus 1. So the opposite of plus 1, I'm going to minus 1 on both sides. Balance in the equation. So minus 1 on both sides, I get root 2 of sine of x is equal to negative 1. Then, this is root 2 next to a sign means timesing. So I don't want to times root 2. I want to get rid of that. Opposite of times root 2 has to be? Divide. So I'm going to divide both sides by root 2. See, I'm just balancing the equation. Exactly what you've been doing since year 7 and now. Yeah? So root 2 divided by root 2 is 1. It's not 0. A lot of students think it's 0. If it's 0, the whole thing's 0. Right? It has to be 1. Then you're left with sine of x is equal to now negative 1 on root 2. So this brings us back to something similar to what you've been doing up here. If you've been doing question 3, that's where you're starting at. Okay? So you rearrange the equation to something like question 3. And then from here, this is where you ask yourself, well, how do I get x? I need to remove the sign. Now, the only inverse of sine, it's not like dividing. A lot of students do this. As if it's I don't know, s divided by s, I divided by I, and n divided by n. That's not true. Okay, sine is like a times symbol. You don't cancel out times symbols. In this case here, it's a function. So what we're going to do is we're going to do the inverse function, which is sine inverse of whatever's on the left, just like what you did with log. Then on the right-hand side, I do exactly the same, and I say, all right, let's do the sine inverse of the right-hand side. So I know it looks all confusing there, but essentially I'm saying these inverses remove or undo each other, and x is equivalent to sine inverse of negative 1 on root 2. Now, this doesn't mean anything yet, but you do need to have that line. Okay, so this is an important line. So don't skip that line. Don't go from this line that we had before and then just right to the answers. This is the layout. Okay, so I'm showing you the layout on how it should be moving. Yep. It's not that you don't, you lose marks. It's just very bad reading. Like if you're reading it, it doesn't have meaning. It doesn't know, like, how did you go from this into x? Sometimes students just jump right into this. Actually, no, they just jump right into x equals 2 and then write down. It doesn't make sense. And this is where errors can come into. So when you're skipping steps, it shows to me that students don't understand this process of inverse operations. That's why we skip it. Whereas they can do these, they're happy to do those, but they're not happy to do this. And that tells me that it's because they don't understand inverse of sine, it's the sine inverse, and all you're doing is sine inverse on both sides. Okay? So my encouragement, in terms of layout, there should be this step before you write x equals 2 and whatever your working solution is. Okay? All right, so now we've got up to this step. This is where you use a unit circle and understanding. So in 14H, let's do this together. I'm going to draw a unit circle. First thing you need to identify is what are you trying to figure out? This is trying to say sine inverse of negative 1 on root 2. What it's trying to say is sine of an angle, okay, I just don't know what angle, but sine is the vertical height. So the y value is at some point when it's equal to negative 1 on root 2. So it's essentially telling you the y value is going to be a negative. So then you look at your unit circle and you say, well, where would sine be negative? Or where would the y values be negative? And as we can already see, it has to be in quadrants 3 and quadrants 4. That's the only two regions where the y value, so I'm going to highlight the y value, this is the y-axis. This is the only two regions where y-axis is going to be negative. We just don't know what the angle is. What is x? That's what we're trying to figure out, right? So to find that out, this is where you go back to your exact value. So I'm using symmetry properties. Now I'm going through exact values. Sine of what angle will give you negative 1 on root 2? 45 degrees in terms of radians. Pi and 4. So I know From here to here is pi and 4 distance, but I know the angle is 45 degrees. So here, this is 45 degrees, and from here to here is pi on 4. That was the benefit of knowing your exact values. If I draw my my triangles now, you can see I've got symmetry properties in terms of triangles. This is the first step. This is why I was saying if you don't get symmetry properties and you don't get exact values right there, you're already stuck. But if you got what I was saying, these are the 2 points I'm most interested in. This point right over here and this point right over here. Those are the 2 points that I'm interested in. So now they say your domain was 0 to 2 pi. So I'm starting from 0 and I move around the circle. I go, yep, I'll keep going. Y values are still positive, 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 positive. So it reaches a maximum 1. Y values now decrease. It gets closer and closer to 0. So at pi, angle of 180 degrees, the y values are 0 here. Then I continue. I want it to be negative. I need it to be negative 1√2. That's when it happens, right here. So at pi, if I add an extra pi and 4, I get my first solution. Then I go all the way across to get to this solution. I know I'm only away from 2 pi by pi and 4. That's why in my working solution, this is where you write the next step. And you write in, first one was I moved all the way here. That was pi, and I know I just need an extra pi and 4. So I write it down. Pi, an extra pi and 4. That gives me the first solution. Then I know if I continue all the way around the circle and I reach over here, that's 2 pi, and that's the domain, 0 to 2 pi. But on the way, I passed another solution. And I know it's only from 2 pi, I only need to subtract pi and 4 to get to that position. So I write here, 2 pi minus pi and 4. And I'm done because I've worked through the unit circle based on the domain they give you. So as you move throughout the chapters, you find the domain will start changing. It doesn't have to be 1 revolution. It could be half a revolution. It could be negative 5 pi to negative 3 pi. You need to be able to work with a unit circle based on the domain. Okay, but to start off with, they usually start from 0 to 2 to get you used to the unit circle. Okay, so here, this is the hardest part. That was the hardest part, really. After that, this is just fractions. This is why you can see a lot of students struggle here. One, they didn't understand exact values, they didn't understand symmetry properties. Then you put them into fractions, it's over. There's a lot of moving parts here. This is why it builds up all the skills that you've done. So from here, pi plus pi and 4, that's 5 pi on 4, and then 2 pi minus pi on 4 is 7 pi on 4. Okay, how I do it, I just do 4 times the 1 plus the 1, that gives me 5. 4 times the 2 is 8. 8 minus 1 is the 7. That's how I do it. Okay, but there you go. So that's my 2 answers if my domain was 0 to 2 pi. So what's the hardest thing of this? It's really not that much extra, but besides understanding what the question's asking, sine of x equals negative 1√2 should give you a platform to work with. So to start off with, I usually tell my students to draw a unit circle, highlight which regions you're working with, and work from there. Okay, so exact values, symmetry properties. This is 14H. For those who are up to date, that's question 3. Question 4, you can ignore question 2, that's a CAS work. Question 1 is something similar to what I gave to you on this sheet here. And then down here, it's more of the same. Don't do question 7 yet, okay? We only do question 7 once I know that your 14H in general is good. Then I introduce another idea of dilations. Because when you squish the graph, that means there's more solutions that you have to account for, and there's a technique to calculate for that. Okay, so question 7 will be tricky. Well, unless you want, you can have a look at example 20. They might be able to teach you there, or you can send me a question on Padlet, and I'll make a video separately. But I want you to start off by mastering question 1 of 4. Okay, so question 1 of 4, you can ignore question 2. Okay, I'll leave that to you.